Thank you. So yeah, I'm going to talk about systemd at the core of the OS. I'll cover a couple of topics. I'm not sure if I will actually make it through all the slides, but that's completely okay. I'll try to focus a little bit on a container facet of systemd, because I mean, you might know the nspawn tool that we have now in systemd, and the big question, of course, is how does that tool actually fit into the big picture? Given that we have Docker and Rocket and LXC and all these other kind of things, why does systemd actually need another container? So this is kind of where I want to go to, and hopefully shed some light in how this all fits into the big picture. One thing I want to make clear is that whatever I talk about here is really my opinion. It's not the opinion of my employer, which is Red Hat, right? Like, so I'm talking here a couple of things. I'm explicitly saying that they're actually not really the opinion of Red Hat. They're pretty much contradictory to what Red Hat otherwise tries to follow. But anyway, just to make that clear, so that nobody quotes me incorrectly. Anyway, so a little bit of the background, like what are we actually trying to do with systemd and what we think that systemd is. For us, like we are OS people, right? Like the systemd community, like the people who develop systemd, we consider ourselves OS people. And of course, because we are OS people, for us, the OS is actually at the core of any software problem. Like, right? We believe that whenever you write a program, you need that OS underneath, and it needs to bring up the system, it needs to keep it up, and it needs to provide basic services to application. And that for us is the OS, right? And you cannot do without the OS, and that's why we believe we should put the OS at the center of everything we do. So more specifically to how computing is done nowadays, we believe that regardless if your applications actually run on bare metal or if they run in containers, we believe that the OS must be there and must provide these services that it provides inside of the container and outside of the container, right? Specifically, this means we believe that systemd or something like it should actually be inside the container as well as on the host, and not just inside. For applications running, the differences between running on the host, right, and running on a container should actually be absolutely minimal, right? We see it as our job as operating system developers to make sure that whatever you do it can be agnostic of the fact that it's run in a container or not, right? This means a lot of different things actually on the lower levels, because containers, after all, are not KVM or something like full machine virtualization. They are much more from the host actually leaks into the container than it does on KVM and things like that, right? So what we believe that for systemd, it's really the job to make those differences go away as far as that's possible, so that application developers ultimately don't really have to think about whether they're actually running in container or not. So let's talk a little bit about containers and what systemd actually has to offer there, right? Like that nowadays, many container managers. Like there's Rocket, like especially at this conference, I guess the most popular one. There's Docker, there's LXC, there's libvirt LXC, there's OpenVZ, and there are a couple of others. So in systemd, we have this thing called systemd nspawn that goes together with something called systemd machined and something else which is called systemd importd. Those three things together are basically systemd's own low-level container implementation. We consider containers a little bit different than, for example, Docker traditionally does it, right? For Docker, what you actually run in the container is really just one application, right? For ours, and what actually runs below that one application, below that container, is not interesting for Docker. They pretend that it was irrelevant what kind of operating system runs underneath and which kind of virtualization technology actually is used, right? We see this very different. For us, containers are an integral part of the operating system, right? They are not something that should be added on top. They're something that should transcend all the layers of the operating system, and that every part of the operating system should actually have a notion of, so that it can expose the user interface nicely with containers in mind, right? This idea of considering containers a part of the operating system is not a new idea. It's not something we came up in the systemd project. If you look around, then you'll actually see that the Laris introduced something very close to the ideas that we have 15 years ago with Solaris Zones, where you basically had one system that would come out of the box with container support, very easy to use, and things like that. Of course, Solaris Zones never got the popularity that containers have today, but I still think it's a good inspiration for many ways, like many things from Solaris actually are. So what we're trying to do with containers really, in the systemd context, is something I like to call integrated isolation, right? So on one hand, it isolates the apps from the operating system so that you can carry your own shared libraries and things like that and don't have to deal with DLL hell. But on the other hand, what it should provide you is a lot of additional integration that, for example, VMs will not provide you with. What that specifically is, I have on a later slide, but it basically means that yeah, everything on the operating system knows containers, and all the operations that you execute on the system are actually executable the same way on any container that runs locally. But anyway, so let's talk a bit about what precisely we added for container support inside of systemd and what kind of, like how it's written. So first of all, what we have in systemd is very, very minimal, right? Minimal means for us that it doesn't have many options, right? It's supposed to provide one solution that works really well, that is very nicely integrated, but that does not try to cover every possible technology on this world, right? It will not have 10 backends for 10 different storage engines and things like that. It will be minimal and nicely integrated. For us, we're operating system people. We care about the lower level parts of the operating system. For us, the focus is always on getting it right? This sometimes comes at the price that what we're doing is not immediately ready for consumption by the broader public, right? Like, we care more about getting something correct into place than getting it out of the door right away. This means for us no hacks. We have clean integrated implementation. That's kind of the primary focus for us. We consider ourselves a little bit more like a research department than actually something that generates ready, like finished products. To give an example of what that actually means, and this is actually, for example, one of those areas where I am not on Red Hat's, this is not a Red Hat opinion that I'm talking about here. So for us, it basically means that instead of using technologies like LVM, we kind of focus on Btrfs here. Btrfs has, let's say, a bad reputation for stability, and probably deservedly so. But on the other hand, we believe that many of the features that Btrfs has are how operating systems, how file systems should actually work, right? They solved a lot of problems with Btrfs that have been inherent to file systems in the last 30 years, but nobody ever wanted to deal with and actually solved right away. So we say, if we deal with containers, we need to think about things like quota, of things like snapshotting, of things like just getting the size of container and these kind of things. We need to make sure that you have ref links and things like that. All of these Btrfs provides. So we say, OK, we develop for Btrfs, even if that means that it might not be readily deployable simply because Btrfs is not a perfectly stable file system yet. We believe it's not as bad as it might appear, because the way we implemented all that in systemd actually means that the host file system can actually be XFS or whatever you like. It will automatically use Btrfs in a loopback device and actually size that loopback device so that you can run your containers in Btrfs, but not the host itself. So you get the stability for the host. And containers generally don't actually need the stability that much because you run them much more parallelized anyway, right? Like, you usually don't run a single instance of a container, you scale them up. And if one of them fails, it's not that much of a problem. So long story short, we kind of say, yeah, if we can push towards Btrfs and towards getting things right, then containers are certainly a good chance to do that because of their volatility and because they are generally not where the data is stored, where it matters, but more where the feature set actually matters. So yeah, and what also matters for us is that we have a defined execution environment that is close to what to expect from the host OS. More specifically, that actually means, it means superficial things. Like, for example, /temp. right? /temp on most operating systems is cleaned up automatically. Since time began, Red Hat had this temp watch thing, and then systemd gained this temp file thing that cleans up /temp, right? It traditionally cleans that up on the host, right? But if you run in a container, the same mechanisms really should apply. So for us, that means inside of your container, you should also run temp files, and it should also clean up temp automatically. And it's a lot of things like that. Like logging should work the same inside of the container and outside of the container, but they should also integrate. What also matters a lot for us is that we open the doors for alternatives, right? Because we know that we have this more central location in the software stack. We are very sure that we should not try to kick everybody else off because we have a better position. For us, it really matters that we have open doors for alternatives. That basically means that most of our components, you can actually use a completely different implementation of things and hook them up with systemd the same way as you can do it with nspawn. Like specifically, if you use libvirt LXC, for example, and run your containers with libvirt LXC, then systemd will actually, it will actually register with systemd as a container, and then you get all the nice integration that we offer the same way as you would do it with nspawn. So, and this goes through all the stack for us. We don't want to be exclusive, and we don't want to actually tell people use nspawn, everything else is bad, because it inherently isn't. Nspawn has a very specific feature set. If you need some of the functionalities that we do not provide, then you should use something else. So for us, it really matters. Open doors for alternatives. What is also important to us is that we want to avoid defining new standards where there already are standards, right? This basically meant for us is we avoided actually defining something like ACI. I mean, it's a good thing that ACI exists, but I didn't really want to, with my low-level stuff, really get into this area of defining such a container format. So our strategy in that area was more like, okay, let's look around. Can we do without defining container format, but still provide similar functionality to what most things like Docker and things actually provide by defining these container formats? And we looked around and actually realized, well, there are already tarballs and there are already disk images, and that's what people use for some container managers. That's what people use for virtualization, like KVM-style virtualization. What would it actually take us to support these formats natively in nspawn, like QEMU would support them? So specifically, this meant that nspawn, right now, you can pass it a GPT or MBR disk image, right? Like the very same thing that you would boot up with KVM or whatever other virtualization software you would use. And you can boot it out with nspawn as if it is, as a container, right? Like you can have basically the same image that suddenly becomes portable between KVM-style full kernel virtualization to containers as well as bare metal. And the distinction to the software running inside should be minimal. Of course, there will always be differences, right? Like we should not, I mean, if you run a container, you generally don't have hardware virtualization, right? So if you have a system that inherently needs some kind of hardware to be around to boot, then it will work fine on bare metal hardware, and it might work fine on virtualized systems because you added a virtual piece of hardware to the thing, but it will never really work on containers because the Linux kernel doesn't really provide hardware virtualization for containers. So there are always limits to this, but for me, what mattered us, and for us in the systemd project, what mattered to us is that, well, if we can avoid defining a new standard, then let's do that and just make everything you already have portable so that you can use it with nspawn, or at least to the point where that's possible. What also matters, to make that clear, like nspawn was originally actually written for testing things, right? I did not have in mind that people would actually ever deploy that on a server. What I had in mind back then is I was developing an init system, and I wanted to test my init system all the time, and I wanted to avoid having to physically reboot my machine, because that's really annoying, and that's slow because it has to go through the BIOS and things like that. So back then I looked around for the container managers, and I wasn't really overwhelmed by the options that there were. And then we started writing this absolutely minimal one, which is systemd nspawn, and it's still very minimal, simply so that we can test our own stuff. And that's what we still use it for every day, right? as we develop systemd, every day we first test our changes by booting it as a container. So what I'm just trying to make clear here is, like, for us, containers are absolutely in the center of everything, because I actually test systemd more often in a container than on anything else. I talk a little bit about, like, what are some focus for us here and what matters to us and what doesn't. But let's really draw the line where actually what does not matter to us. So cluster-wide orchestration, these kind of things that Rocket provide or Kubernetes or whatever provide are clearly not in focus for us, right? We are the low-level guys. We will not, like, we don't really care how you get the, how you deliver the containers to the machines. What we will provide you with is how the containers actually run on the machine. If you want all that kind of orchestration stuff, then build on top of that. Yeah, it makes a lot of sense to use nspawn and build something completely different out of it. And this is actually used by Rocket, right? Like Rocket, if you use it, it will actually internally just invoke nspawn to do the low-level bits of namespacing things and running things. And that's absolutely the right way to do. That's how we want to be used, right? We want to be this low-level building block that's just there, that just works, that will not solve all your problems, especially not if you have more than one machine. But other people can write the stuff around it, the toolset around it, the networked stuff around it, that actually makes it really, really useful across machines. So much really about why we did what we did with nspawn, and a little bit of the background. Let's now get a bit more specific on the various components that we actually have in systemd for containers. So one of that is machine control and systemd machine D. That's a daemon that usually you should not really see, like systemd machine D. Its only purpose is to keep a list around of the locally running containers. This is particularly useful so that you can, I don't know, list the current containers, that you can introspect the current containers, or that you can execute operations on the current containers. It's a relatively passive thing, right? Like it has a couple of operations that it can execute on containers, but mostly it's really just this registry, so that if you run 10 nspawn containers and 10 libvirt LXC containers and 10 whatever else containers, they all register with this machine D, and machine control is a client command to actually interface with it. In the current Git version of systemd, it's actually a really, really powerful tool, machine control. It can do superficial stuff like just showing the process tree of the container that you have, but it can do other stuff as well. To clarify this again, any container or VM manager can register its machines with it. Like, we always use the word machine, by the way, in the systemd context. We use it as a generic term for both VMs, like KVM-style hardware virtualization, and for containers, meaning OS containers that actually use the same kernel. So the word machine we usually pick as a generic term for both. So, and hence machine D actually is happy to register both kinds of things, right? Like KVM as well as nspawn or libvirt LXC, whatever else you want to use. What does that actually give you? It gives you a lot of integration into the rest of the systemd system, right? You can do system control -m, which basically executes the operation you're specifying, like system control start foobar. If you add the -m and specify a local container name, then we'll execute that operation inside of that container. There are system control list machines, which actually shows you the service health status of all your local containers in a nice list. There's login control -m, which basically is what system control -m is, except that it shows you everything about the local sessions, users, and seeds that are available. There's journal control -m, which shows you the logs of a specific local container. Journal control -m, you specify a local container name, and it will show you the last logs of whatever that's in there. If you avoid that, it will show you of the host. If you add it, it will show you of the container. Journal control -m will actually merge the logs of all local containers into a single stream. It will interleave them nicely by time and show them as a single linear log. But it doesn't end there. There's also integration with PS, the good old PS Unix tool. You can type PS-EO machine PID, whatever else columns you want, and then we'll show you actually for each process that runs on the system to which container or virtual machine it actually belongs. It's really, really useful. Similar, like if you use graphical system, GNOME System Monitor has been updated as well to show this information. So They show basically, yeah, well, everything about machines. Then there's a couple of other systemd-related jobs, tools. There's systemd run-uppercase M. Systemd run is a really, really useful tool, actually, which allows you to run any command line that you want as a systemd service dynamically without having to specify a systemd unit file, right? And with systemd run-uppercase M, you can run whatever you want to like every command line in any local container. It's really, really useful if you just want to execute some command in some local machine. You just type in systemd-run -uppercase M, my container name, and the command line, and that will be executed. There's also machine control login, which basically opens you a shell for you in any container manager you like. Like if you use libvirt LXC, if you use Anspawn, it doesn't matter. With machine control login, you get a new login into your container, as if it was like you basically get the prompt, which asks you what's your username. It starts a getty. There's machine control stop and a couple of other machine control commands that operate on the containers generically. It also goes as far as it will provide you with automatic hostname resolution. You know, hostname resolution is like DNS, but only on the local machine. It will resolve all local container names to the IP addresses they use, right? You don't have to do anything with that. You don't have to, for that, you don't have to set up a DNS server or do anything. It will just work, right? Like if you have a local container and it uses network namespacing, then because NSS My Containers is used on the mono distros, the IP addresses will be automatically resolvable under the machine name, right? You can just, if you start a container, call it foobar, that's already enough to be able to ping it. You just say ping foobar, and it works. But it's not only about this integration into all the various tools that the admin is exposed to. It goes down to the APIs we provide as well. Like, for example, there's SDBus, which is our own dbus library that we have developed in the systemd context. And it exposes things like, I want to connect to the system bus, not of the host, but of any container you like. And it's completely transparent. Like, it's really, really nice to use. So the point I'm kind of trying to make here is, by using machined and by integrating containers into machined, regardless if it's Anspawn or something else, you get this really, really strong level of integration. It feels like service management is not locked to the host, but it actually, if you want it, I mean, it goes further, and there's like something that I didn't manage, for example, system control-R. System control-R recursively enters all the local containers and shows you basically all the services on the host and on the containers in one single list. Which is, I mean, I think it's absolutely necessary to provide this kind of integration because, I mean, think about it. What do you use containers for, right? Like you split up your Apache instances and your MySQL instances and whatever else in individual containers, and you still want to know what's the service health inside of these individual containers, and you want to have that in a single list. So that's why you have system control-R. So there was so much about what machine control, machined do. Let's talk about the main tool that there actually is, which is systemd Anspawn. It's a minimal container manager, right? We make no attempts to cover all the use cases that there might be from container managers. We do not try to be another LXC. You know, LXC is this low-level tool that was used by Docker initially. It tries to support everything possible in the world, and that has anything to do with namespaces and containerization. That inherently means it requires configuration. What we say, we want a container manager that just works without configuration if possible. And that's what Anspawn is, right? It will not give you a lot of options, but you can just point it to a directory that contains an operating system, and it will just boot it up, and it will just work. So it integrates nicely with systemd machined, of course. Systemd Anspawn, you basically, we literally run a container as a service with it, because the idea basically is that every time you run systemd Anspawn, it invokes a new container. So you basically, if you have n Anspawn instances, you have n containers. And in many ways, using systemd Anspawn fields, like is how to use the qemu kvm command line, but for containers. Except that our command line, I think, is a bit nicer than qemus, but I guess that's a matter of taste. Yeah, you pass it a directory and it will boot it. Even though you can pass it any directory you want, the preferred directory is in valid machines. If you place something there, which is just an operating system image, then it will just boot that. I mentioned this earlier because we wanted to avoid defining new container formats. it will actually disassemble GPT partition tables and a couple of other formats like MBR automatically and boot the raw disk from it, right? So again, this is about being able to use the same disk images and boot them up in KVM and NSpawn and on bare metal without any differences. I already mentioned that this container as a service thing, right? Like every container becomes one systemd service. And that means a lot actually because you can start and stop the containers individually, and service, like resource management for the containers works exactly the same way as resource management works for any other service, right? So here's an example. You can type system control set property. Well, there's actually a T missing, sorry for that typo. Then you specify the service name, which is systemd nspawn at whatever container name you use, CPU shares equals 100, and that sets basically the CPU shares. And like, to understand that, you kind of need to know C groups and how this kind of resource management works. But effectively, this command line will make sure that this container gets less CPU than most other containers. CPU shares defaults to 1000 and relatively evens out the CPU. This command line actually works the same for any other service. Like if you would have a local service, mysql.com or something, you could just run that the same way and would just work. I'm running a bit short on time. So quickly on the other component that we think that make up a good container stuff, there's systemd networkd, which is a network management solution. It's a little bit like network manager, but with a better reputation. Networkd is very minimal, it's very low level, it's very dynamic, and it can run inside of containers and on the host, right? It can do basic things like DHCP and things like that, but what is important for us is that we want to implement it properly. So it does DHCP actually on its own. It's not this glued together shell script monster. It actually has its own DHCP implementation, its own IP4LL implementation, so that's really, really minimal and doesn't pull any dependencies in. It just does these things. In contrast to what many people might think, DHCP is actually not the most complex protocol in the world, so it actually makes a lot of sense to do that in networkd directly. It has container support by default. If you use it, then you get DHCP server on the host for all the connections to NSpawn. Just in the default configuration, you don't actually have to do anything for it. The other way around as well, like if you run on the host and inside of the container, you get completely automatic network without any manual configuration. The last thing I want to talk about is systemd resolved, which is something, it's about name resolution, because we thought, well, the way how traditionally you reach different machines on your Unix network is by host names, right? And if you run multiple containers in the same virtual circuit, you still want to be able to use host names to reference them. So we wrote this resolved, which is primarily a DNS caching daemon, but it also is an implementation of a protocol called LLMNR. LLMNR is linked local multicast name resolution. It's a protocol that Microsoft invented 15 years ago or something, and which is a part of pretty much every Windows release since. What it does basically is link local name resolution, right? Like if you're on the same physical link on the same broadcast domain, then you can use it to make machines that know their own name to reach all the other machines on the network without having to have a central registry of things, right? Like, so in essence, like if you have your virtual circuit with your MySQL and your Apache server, and both of them run systemd resolved inside of their containers, then simply by giving them each a host name, they can ping each other with the other host name without any further configuration, without any kind of setup for central name specifications or anything. It will just work. Of course, it used to be a technology that was used primarily for end user devices, but it's incredibly useful, I think, on servers as well, simply because it really removed this problem of having to like configure the IP address and things like that of containers between each other. But anyway, my time is mostly empty, mostly over. So let's have a couple of questions. If there are any questions. Are there any questions? There's a question.
Could you or somebody in the audience say what's the current status of systemd and the various utilities and integrations for containers in Debian and Ubuntu?
So 2 weeks ago, something, Debian and Ubuntu released their first versions of the distro with systemd. So basically, every distribution now does it except for Gentoo, which has it in the distribution but is not the default, and for Slackware, which probably will never have it, I don't know. But all the other distributions that are popular, and especially all the enterprise distributions, have it now. There's a question?
Earlier on, you were talking about the reliance on ButterFS for the container file system. It kind of seems like ButterFS development has more or less stopped, and I'm wondering if that could become a delay.
I don't think it has stopped. I mean, I talked to Chris Mason and Batchik, like the guys that working on ButterFS frequently, and they are working on it all the time and at Facebook. And they're working on new features and fixing things. So I think the community is pretty active. So I don't think it's stopped, but I don't know. So one last question, and then.
Yeah, the systemd resolved it. What relationship is that bear to the Avahi MDNS stuff?
That's a very good question. I also wrote Avahi years ago. Well, I mean, that's basically the reason why I came up with using LLMR suddenly for containers in the cloud, because it's not the obvious thing to do. LLMR and MDNS are kind of the same thing. One is done by Apple, the other one is done by Microsoft. The Apple thing does more than just name resolution, it also does service discovery. It is our intention in ResolveD to support both, but I so far didn't have the time to actually sit down and do it. But basically, a ResolveD shall replace Avahi in the long run, and so that everything is the same there. And you don't really have to think anymore about what actually is used there. It's just the default that is there and just works. Okay, I think that's my time. Thank you very much. And